So, answers to the questions I gave you for homework. If you were away, you need the new booklet. It's right here. Oh boy. Big roll. Hands up if you do not have the new booklet. Dang. Okay, casually talk amongst yourselves. I'll be right back.
I left mine out.
Casually talk amongst yourselves. I'll be right back.
Write down his hat.
Yeah, the notes and stuff. How's your weekend? Yeah, do anything fun and exciting? You did?
Not in this
Okay. Garrett. Here you go. Still. There you go. Jared. Now you have one?
Are you ready for the movie?
Yeah, I'm ready for the movie. Are you ready for the movie?
Yeah.
Too bad the movie doesn't work.
No.
There you go.
I'll bring my
Do you have one of these, Juno?
yeah.
Get it up. Anybody else missing this?
Spring break. We have winter break.
Okay. Did someone ask when spring break was? We have a little ways to get to spring break. Yes. Yes, you were. So when are you going to write it? Okay. Well, figure it out. Let me know. You're asking about winter break. The closest break we have, okay? Here we are on the 25th. Yeah, it's my wife's friend. That's my wife's calendar. All the blue is her. So here we are on the 25th. We go all the way to the 20th. Yeah. So we've got that 1, 2, 3, 4 weeks. 4 weeks, 5 days every week.
5 days.
20 school days. Okay, here are the answers to the homework I assigned. There we go. In the first table, all you had to do is tell me how many terms there were in this object, and then name it appropriately. So terms, for those of you who are away, are mathematical objects separated by addition or subtraction. So because I have addition here between these two objects, that is a two-termed thing, and we call two-termed objects binomials. There is no addition or subtraction, so it's a one-termed thing, it's a monomial. We have a three-termed thing here because it's this plus this minus this, trinomial. 3 terms, trinomial. And so on. Comments, questions, concerns from anyone? Hassan, put your phone away. This is your one, no, away, yeah. If this is your one warning, if I see it again, I'll take it from you. Yes, Garrett. No, this is the one warning for everyone. Hassan's was the warning for the class. Yes, Garrett, what was your question? Okay. Oh, and if you were away, we have special names for the first three, the monomial, the binomial, and the trinomial. But anything past trinomial is called a polynomial. Abdullah, if you'd like the mechanical ones, they're right here. I moved them. Okay, here we go. The next chunk was asking you guys to tell me the degree of each term and the degree of the polynomial. If you were away, the degree of a term is the sum of the exponents on all the variables in that term. So this one would just be the 2, this one would be the 1, and then for the degree of the polynomial, you just pick the number that's bigger. That's why I'm explaining what I'm explaining, yeah. So because there's no variable here, that means the exponent is a 0, which means the degree of the term is 0, and because it's the only term, that means the whole polynomial has a degree of 0. This one, the exponent is a 2 on this term, and again, it's just on the letters. So the exponent's a 2, so the degree is 2. The exponent's a 1, so the degree is 1. There's no variable, so the degree is 0 for each individual term. And then for the whole polynomial, you just pick the biggest number. The biggest number of 2, 1, and 0 is, of course, 6. Yes, Liam, where were we without your quips? Not getting quite so confused. This one has a degree of 2. This one has 3 letters that each have an exponent of 1. So for this term, you have to add those 3 ones together. This invisible one, that invisible one, and this other invisible one, which I have now made visible. So the degree of this term is 3. The degree of this guy is 2. So because I've got a 2, a 3, and a 2, the whole polynomial has a degree of 3. The biggest of these 3 numbers is the degree for the polynomial. And then this guy is 0, 1, and 2. So the degree of the whole polynomial is 2. Then we've got the coefficients and the constants. The coefficients are whatever number is multiplied in front of a letter. So when there is no number written, it's a 1 or a negative 1. You have to include the sign out front. So this one would be a 1, this one would be a negative 1. And constants are terms that have no letters, just numbers. So because there are no just numbers, the constant here is 0. This one has no letter, so there are no coefficients. But this thing has no letters, so that is the constant. So the constant here is 5. The coefficient is 0 because there's no letters. This one, the coefficient here is 2 and 4. The constant is negative 3 because you have to include the sign out front. This guy would have a coefficient of 1 because there's no number written. It's assumed to be a 1. This one would be a 3. This one would be negative 1. And this guy has no letter, so that's the constant, 4. This guy would be 2, negative 4, and 1. There is no term without letters, so the constant is 0. This guy would be 1. This guy would be negative 1. And there are no terms without letters in either of those 2 questions. So the constant's there as well, 0 and 0. Sorry? No. I'm halfway through. Okay, so flip the page. Find me this guy. Still no bed mass. No bed mass. Still no bed mass. I'm looking out for you. There is no bed mass in this.
Like the entire book?
Correct.
I love life.
And do you just dislike bed mass? What if we undid bed mass? What if we did the opposite of bed mass?
What's the opposite?
Samdeb.
What's Samdeb?
It's the opposite of bed mass. It's just backwards. Yeah. Yeah. We don't like that either? Oh, that's the same as bed mass. PEMDAS and bed mass are the same thing.
What's the P though?
Parentheses, which is just another fancy word for brackets. Okay, if the grip tester becomes a distraction, I will take that thing away as well. There we go. So we're going to look at collecting like terms today. What's a like term, you might ask? Hassan, put the grippy thing away, please. So, like terms in, yes, Garrett.
Are like terms we like 2x times x2. And the 2 has an x2, so is that like a equal?
So you're saying this one is an x squared and this one's an x squared?
Yeah.
Yes, that is a like term. So to determine whether or not we have like terms, what we need to look at is whether or not the terms have the same variables. This first blank is variables. I put the words letters in brackets, so that might have been a hint. You have to have the same variables, and they have to have the same degree. But I don't like thinking about them as being degrees, so we're just going to write the word and then we're going to cross it out. What I want you to look for is the same variables with the same exponents. Each variable, Denny, Liam's trying to hand you something, is that each letter has to have the same exponent in each case for the two objects to be considered like. It doesn't matter what order they're in, incidentally. But the letters have to be there and the letters have to have the same exponents. So, for example, Garrett already said it. I've got an x squared here and a 2x squared here. The letters are the same. They're both x's. The exponents on those letters are the same. They're both 2's. It does not matter what number is out front. Those are just the coefficients. So yes, in fact, these are like terms, as Garrett guessed correctly. So let's take a look at the second one. I've got negative 2x cubed and a negative 2y cubed. Are the letters the same? No. So because the letters are the same, it doesn't even matter what the exponents are. The letters have to be the same, and the exponents on those letters have to be the same. X's and Y's are not the same thing, not a like term. How about this guy here? They're both Y's. The letters are the same. Are the exponents on those letters the same? Yes, it does not matter what the number out front is, but the letters are the same, the exponents are the same. Are you writing anything down, Hassan and Harsh? Yes. Those are, in fact, like terms. Take notes with me, gentlemen. Okay, and then I throw you a little bit of a curveball down here. I've already said that the order does not matter. You just have to have the same letters with the same exponents. The first one, I've got a yx squared. Is there a y in the second one? Yes. What is the exponent on this first y? If it's not written, it's a 1. What's the exponent on this y? Nope. Take a look again. What's the exponent on this y right here? It's also a 1. There's an x here with an exponent of 2. Is there an x over here with an exponent of 2?
Yeah.
You betcha there is. So it does not matter what order they're in. It could be yx squared, or in this case, x squared y. Because the letters are the same, and they have the same variables, these are also like terms. The answer is yes. I see that hand. Yes, you may. Real quick, which you're really good at. If you do not see a coefficient, then the coefficient is an invisible one, which we talked about on Friday, which we'll talk about here again. So the coefficient on this guy is 1, and you have to include the sign out front. So the coefficient on this guy is going to be -1. The coefficient on this guy is a 1, you betcha. And the coefficient on this guy is a you bet. The reason we're reviewing coefficients here again for what feels like the second or third time today is because we are going to start collecting these like terms and grouping them together using their coefficients. So, if you have like terms in your expression, you can simplify the expression by collecting like terms. So let's take a look at that first. I've got x plus x plus x plus x plus y plus y plus y. I've got like terms here. I have multiple objects that have the same letter with the same exponent. There's an x to the power of what here? 1, you betcha. All of these things that don't have exponents written have invisible 1s up top. So my exponents are the same, and the letters, wherever you have equivalent letters, we can group these things together. So I've got 1x plus 1x plus 1x plus 1x. You betcha. That's going to equal 4x. Because all we've done is we've taken the coefficients out front, In this case, they're a bunch of 1s, and I added them together. Yes, Jordan?
I added all 4 x together and I got 20.
Yeah, don't do that.
What?
Don't use your calculator for this. No, do not put, so you Jordan, you got to stop doing this. You keep trying. Now you're really excited to use the letters on your calculator. Don't use the letters on your calculator. Because your calculator assigns values to those letters. So don't use the letters. Just don't use the letters. This is not a calculator question, Jordan. This is a, what is 1 plus 1 plus 1 plus 1? You should be able to do that with a calculator. So you group those up. I got 4 of them. And what are the thems that I have 4 of? Well, x's. So that's just written as 4x. Now I've got more things to group. I've got a bunch of y's over here. These are like terms because they're the same letter. They have the same exponent. And how many of them are there? There's 3 of them. And they're all positive. So this is going to become plus 3y. That's it. Now, of course, this gets more complicated. Now I'm just going to bring in more objects. I got a bunch of 1s. I've got some x's. I got some y squareds. So what are my like terms here in question B?
X1 and 1.
All the x1s are like. All the y to the power of 2s are like. And these constant terms have no letters, so they're also like. So a method for you guys to keep track of your like terms is to put shapes, and this is the way I recommend doing it, putting shapes around the like terms and then adding up equivalent shapes. For example, that guy, and that guy are all like terms. If I put circles around those. Garrett, you said the x's, so I've got an x there. I'm going to put a square around. And this guy are all like. The letters are the same with their exponents. And you want to make sure you include the sign out front. This guy here, I'll put a triangle around. This guy here, I'll put a triangle around. Those are like as well. They're both y's, and the y's are both squared. So if I've got a bunch of 1s here, 1 plus 1 plus 1 is 3. I've got this positive x, and positive x. How many positive x's do I have? Plus 3x. And then I've got how many y squareds? 2. So I'm going to go plus 2y squared. You're grouping the like terms. You're not changing the term. So the term is y squared. The term here is y squared. How many y squareds do we have? 2 of them. That's it. When you multiply them is the only way you can change an exponent. And we're not multiplying them, we're just adding them together. Y squared plus y squared is 2y squareds. It's like when I add fruit together. I don't take an apple and another apple and get some other kind of apple. Apple plus apple, 2 apples, not a pear. That would be weird. Okay, the other little snaggle here. Yes, Hassan, I saw that hand. You have a question? You are correct, it is. It is, in fact, 4x plus 3x squared. So yes, Zach, can we use the washroom? So take a look here. I've got these 2 x's and these 2 x's, and then I've got an x squared there and 2 more x squareds there. So Hassan said, yes, this is 4x plus 3x squared. Now, the little snag we're going to add here is there is a correct order for these things. And the correct order goes like this. By highest degree, and then alphabetical. So, here's what I mean. Let's go back and look at A for a second. We had 4x plus 3y. What's the degree on this term? Remember, the degree is the exponent on the variable. The degree of this term is? What's the exponent on the x? Is a 1. So the degree here is 1. What's the exponent on the y?
1.
So the degree is 1. So they have the same degree, so we can't go by highest degree, so we have to go alphabetical order. This requires you know your alphabet. What comes first in the alphabet, X or Y? X comes first. So this is in the correct order. The degrees are the same, and then it goes X, then Y. Done. Let's take a look at the next one. I've got 3 plus 3x plus 2y squared. What's the degree of this term? If there is no letter, the degree is? So first I'm looking at each term's degree. What's the degree of the number 3? Remember, the degree is the exponent on the variable. If there is no variable, the exponent is a 0. So this 3 has a degree of 0. If there's a letter with no exponent written, the degree is? So this thing has a degree of 1, and this guy has a degree of 2. So if I'm ordering these things, which one has to come first?
2y.
The 2y squared comes first.
Then 3x.
Then the plus 3x, and this 3 is positive, so we're going to go plus 3. So we order first by highest degree. This is degree 2, then degree 1, then degree 0. None of them have the same degree, so we don't care about the alphabet. We're done. This is the correct order. So then Hassan said, well, the second one is 4x plus 3x squared. This is correct when it's grouped together, but is that the correct order? What should the order be?
3x2 and then 4.
With what between them? This 4x is positive, so what do I have to put right here? A plus. That is the correct order for this guy here. It doesn't change what it's worth, but we have convention in math. It's like when you're learning, go for it, rip open what you're going to rip open. It's like learning grammar or punctuation or stuff like that in English. There's a comma needs to be here. Is it wrong without the comma? Well, not necessarily. It could mean the same thing or not, depending on what you've got or why the comma is there. But we put the comma there for certain reasons to make it punctuationally or grammatically correct. So we do this in math as well. You're correcting your math grammar, which whoever thought that math grammar would be a thing? You can have gum so long as it doesn't end up under my desks. Okay, next one. I've got xy, yx, x squared y, yx squared, and a yx here. What are my like terms? The xy is like with what other term? It has to have the same letters, and those letters have to have the same exponents. So this one has a 1 and a 1. So this one has a 2. So is this one like with this one? No. Yes, Garrett, I saw that hand.
xy, 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 and then x.
I only have one xy.
No. Oh, never mind. Yeah.
But what else? What are you referring to? The order doesn't matter. So what are we looking at?
Yx and yx.
The two yx's, you betcha. This yx over here and this yx over here. For exactly the reason Ethan said. It doesn't matter within the term. It doesn't matter if it goes xy or yx. These are like if the letters are the same and the exponents on those letters are also the same.
One question, I'm a little confused because I got back a little late. So how do we start the groupings?
How do I start the which?
How do I do this?
We're grouping the like terms. We're taking the things that are similar and we're adding them up or subtracting them as the case may be. I'll come back to the top one as soon as we finish D. So I've got an xy, an xy, a yx, and a yx. We've said the order doesn't matter, so these ones must be like. So if I've got one of these, and one of these, how many do I have total? 3 of them. So I have 3, and I have to make them, I can't write xy and yx. So I have to pick an order to put them in.
YX. XY.
There you go. We want to keep things alphabetical where we can. Alphabetical. If you don't know the alphabet, X comes before Y, followed by Z, and then you're done. Yes. By just launching into it like that, you remind me of my son, who spontaneously at the dinner table, he's 2, will just launch into the alphabet song. Totally silent. A, B, C. Yep, we got you, big guy. You got it. I love it. You do that too? Nice. So we've grouped these 3 together. Are there any other sets of like terms? Dakota says yes. Dakota, what are they? X, well, squared. Yeah, so this x has a squared, and then this y is just a 1. This one has a y to the 1 and an x squared. You betcha. So this and this are like, even though the order is different, the letters are the same, and the corresponding letters, Hassan, look over here, take your pencil, write the things, unless you've done it already, are the same as well. So how many do I have? 2 of them. It's positive, so I'm going to have a 2, and I got to pick an order. We're going to go alphabetical, x squared y. No. I'm trying to teach you something. Don't make it. And you asked me a question. No, but we're on a 1, then that's the same. So if you don't know, if you interrupt me doing this question by trying to buy gum from Hassan, what's the correct order for this question? The correct order is by highest degree, put your gum away. Ethan cannot have gum until I'm done. Followed by alphabetical. What's the degree of this term?
0.
The degree is the sum of the exponents on the variables. Well, this one has a 1 and this one has a 1, so the whole term is degree 2. What's the degree on this one? 3. So then this one has to come first. 2x squared y plus 3xy. This 3xy is positive, so we go plus 3xy. Yeah. So going back to the first one, it's the same thing. These x's are all like, because they're all the same letter, and the exponents are the same, x to the 1, x to the 1, x to the 1, and x to the 1. The coefficients tell you how many you have. So we have one of these, one of these, one of these, and one of these, which is 4. Yes. And 4 what? Well, 4 x's. And then what else do I have? Well, I had a y, and a y. So how many y's do I have? Well, 3 of them. And they're all positive. So it's going to be plus 3y. That was it for letter A. You see how letter D and letter A were very similar. And why I might want you to pay attention to letter D before we go back and look at letter A. Okay, let's look at E. What are my like terms there? Anybody?
2 XY and XY.
Okay, I've got an XY here, and you got to include the sign out front, so I've got a plus XY, a plus XY. Are there any other things that are like with those two?
The YX.
The plus YX at the back, you betcha. So let's group them. I've got one of these, and one of these. So how many XYs do I have total?
3.
There you go. So I'll write it as 3XY.
XY. Oh, alphabetical.
3XY, you betcha.
I did.
Okay, someone give me another like term.
2 X2Y, X2Y.
I've got an X2Y and an X2Y. Do I have anything else that's like with those?
Yeah.
Yes, Sahil. The YX2 is like with those, because it doesn't matter what order they're written in, YX2 or X2Y. Denny. I want to wait till I'm done. So, how many X2Ys do I have, or X squared Ys? I have 3 of them. So I've got 1 here, 1 here, and 1 here. So I'm going to have plus 3 X squared Y. And if you look, there's still some other stuff there.
The 1.
The ones, plural, there's 2 of them.
Wait, there's 2?
There's 2 of them.
I knew that.
You got to make sure you get all the pieces. So I've got a +1 and a +1. +1 + 1 is?
2.
+2. In this case, I didn't use different shapes, I used different colors. But most of you guys are borrowing my pencils, and so I know you don't have different colors. But it's a useful way to track all the pieces. So if you've got pencil crayons, feel free to use them. I got other grade 9s who are using pencil crayons for this.
So for B, I just like, those are just numbers. I just like 1 + 1 + 1 is 3.
Yep.
That's inside until you need it.
Yep.
Okay.
And then I have an x plus an x plus an x, which gives me 3x's, you betcha. So then is the last one letter E in the correct order, Garrett?
No, it's 3x2y.
3x squared y.
Plus 3x1, and then 2.
You betcha. In order of degree. This one's degree 3, that's degree 2, that's degree 0. Well done. We're going to make things more interesting here. The order, we've said it already, I'm just going to write it down here, formalize it for you guys. The order of the variables within a term does not matter. xy is the same as yx. We've said that a dozen times now. So let's just write it in there so we have something to refer back to in case we forget. And then I want you to flip the page. I have 8 more examples we're going to do together. And then I will free you to math on your own. Yes. Everyone other than Ethan flip. Which one did you get wrong?
B.
Okay, well you have 3 1s here, which gave you 3.
3, and then I got the y2 and y2. That would be what? 2y2.
Yeah. And then there's an x there and 2 more x's there.
So that should be 3x.
Yeah.
I just don't know how to put the order in.
So you order them by degree on the term. So because the exponent here on the x is a 1, this term has a degree of 1. This one has a degree of 2. And because there are no variables here, the degree on this one is 0. So it goes this one first, then this one, then that one.
Oh, I understand it now.
Perfect. Okay, flip. Here we go. We got 8. Now, all of those first 5 questions had 1s everywhere. We're going to get rid of the 1s and we're going to bring in more interesting numbers, like 5 and -3. So let's take a look at this first stack. I have the coefficient out front just tells you how many you have. So I've got 5 n's here, and I'm taking away 3 n's. So how many n's do I have left? Well, I have 5 n's, and if I take away 3 n's, I have 2 what? N's.
I'm in.
It really is that straightforward.
So if I had 3 plus 7.
So Ethan wants to look at the next one on top, so let's do that.
10A, right?
If I have 3 A's, and to that I am adding 7 A's, you betcha, it would be 10 A's.
Now it's getting extremely harder.
No, it's not getting extremely harder. It's getting marginally more difficult, not extremely harder.
Hand this to my brother.
Here we go. I don't care what your brother can do. I want to know what you can do. Here we go. I've got -2x squared minus y plus 2y minus 3x squared. So now all I've done is I've done the exact same thing I did here, but now I did it twice with different letters. I've got n's and a's together. In this case, x's and y's together. So the important thing to do is to identify what your like terms are. Zach, wake up. Nobody asked you, Ethan. Is to identify your like terms and then group them afterwards. So again, when you're looking at like terms, all you care about is letters and exponents. So in this first term, I have an x squared. Are there any other like terms with the x squared? You where, Garrett? It is not 3x2. You're so close. I've said it before, but it hasn't mattered up to this point. You have to include the sign out front. So it's not 3x2, it's -3x2. You have to include the sign out front. So I've got a -2x2 and a -3x2. Let's hold that for a second and identify other like terms. Here I've got a negative y. Do I have any like terms with negative y?
No. Yes.
Dakota, the positive 2y. Like terms have the same letters, and those letters have to have the same exponents. So I put a box around the negative y and a box around the positive 2y, and now I'm going to gather my circles and my boxes together.
Wow.
I have negative 2x squared minus 3x squared is negative 2 minus 3 is negative 5. Negative 5 what?
3.
Nope, negative 5x squareds. And now I've got negative what? If there's no number written, it's a?
1.
Correct. So I've got a negative 1 plus 2 is?
Negative.
Negative 1 plus 2.
Is negative 2.
No,
1. Negative 1.
it's positive 1.
Positive
I meant, you have to take a look, remember the number line. 0, there's negative 1, and I want to go up 2. Up 1, up another 1, brings me to positive 1.
I can't see.
Going that way. Sorry.
I can see.
I'm at negative 1, going up 1, 2. So I'm going to have a positive 1y. Now, when the coefficient is a 1, do I have to write the 1? You just wait a little bit to go to the bathroom?
Can I go as well?
No, you just went already.
I
You don't get to go
I
again.
chugged a brace, man.
That's not my problem.
Not,
Hold it. When I've got a 1, do I have to write the 1? No. So you can write this as negative 5x squared plus y. These are the same thing. And in this case, the order is correct. So let's take a look at the one right beside it. It's very similar. No, you can't. Sit down. I'm teaching you things. I let Ethan go earlier because it was easy. Now you come back and it's slightly more difficult. So no, now I'm not letting you go.
Yeah, it's horrible. I can't figure it out.
This is exactly why I'm not letting you go to the bathroom right now.
5 grand plus 8.
Okay, so Ethan, let's identify the like terms first.
5K, I guess.
And we're doing this one over here.
Oh! A.
I've got an A and,
And every other A.
okay, well, how many A's do I have here? I have to include the coefficient and the sign. So it's not just A, it's
8.
negative 2A. Okay, so before we gather anything, let's group more like terms. What other like terms do I have? I've got an A2, a positive A2, and a negative A2, or A squared.
And then 5.
And then 5's all by his lonesome, so let's put a triangle around that.
4, 5.
Poor 5. Maybe 5 likes to be alone, who knows? Okay, so let's group these things. I'm going to start with the squareds. What's negative 1A squared plus 1A squared? Negative 1 plus 1 is? Negative 1 plus 1 is 0. These cancel out, they're gone. If I have 0 A squareds, don't write them. They're gone. Let's move on to the A's. If I have A, and I'm taking away 2 A's. If I just have an A, that's 1A. 1 minus 2 is? I'm at 1.
1.
Negative
It's
1.
negative 1. So I have negative 1 A's. And then a plus 5 is all alone. It has no friends. So we're just going to tuck that plus 5 there at the end. So I've got negative 1A plus 5. If you wrote it as negative A plus 5 without that 1 in there, it means the same thing. So Ethan, you wanted to do the next one, so let's do the next one.
Yeah, if I have 5 grand and I have plus 8.
Careful. Don't do that. That's going to confuse you. You said before I had 5 Ks and a minus K. Those are, in fact, like terms. So let's put boxes around those, including the signs out front. Are there any other like terms?
No.
What? The 8, it's not 4. It's negative 4. So it's plus 8 and negative 4.
How are they alike?
They have no letters. They both have no letters. So what is 5k minus k?
5.
No.
K.
If I have 5k's and I take away a k, how many k's do you have now?
Okay.
You have 4k's. Yeah. That is what subtraction means, Ethan.
I'm thinking of it as random.
No, don't do that. That'll confuse you.
5 random.
No, don't do that. And now I've got 8 minus 4. It's positive 4. So we're going to put a plus 4 there and we're done.
So we're done that one now?
That's done.
Can I go on?
And no, because we got 3 more. Okay. If you want to go to the bathroom, Jordan.
4M and 6M.
I have a question.
Almost. You're so close. Yes, Jordan, what's your question? Before Ethan's class will be over soon, I'll let you know.
How am I almost close?
Why are people yelling? Why is Mr. DeVries yelling about me?
-2, 2 and positive 3 and
Okay, careful, careful, careful. Now you're just saying stuff. Liam, where are you going?
something.
Garbage for your gum? Are you leaving the classroom? Don't do that.
No.
We're not. No, I didn't. We're not done yet.
You're like, go to the washroom.
No, I didn't.
I said, he said do 3 more.
Whereas if he has to go to the washroom, I said, no, I got 3 more. Okay, I have 3. Minus 4m plus 2 plus 6m. Slow down, Ethan. What is like with the 3?
The 2.
The positive 2.
Yeah.
Fantastic. Then my next thing that doesn't have a buddy yet is negative 4m. Do I have any like terms there?
Yeah.
What is it?
6M.
The negative 4m and the positive 6m. So let's group them. What's 3 plus 2?
6.
Try again.
3, oh, 5.
Because we're adding. We're not multiplying. 3 plus 2 is 5. And then negative 4m plus 6m is how many m's?
2M.
Is how? Sorry?
2, -2M.
Is it positive or negative? I'm at negative 4. I'm going.
Positive.
Pick one. I'm at negative 4 going up 6. It's plus 2m. Is that the correct order?
No.
It should be.
I only said that because if you asked us.
Yes, Garrett. 2m plus 5. Well done. Do you guys feel like you're getting the hang of it? You want to try the rest on your own?
No.
Okay, then let's do them together. I'll stop talking whenever you guys want. So, but you don't want, so let's go. I've got 3x minus negative 2y, oh boy, minus 6x minus 3y plus 3. This is gross.
Yep.
The first thing we should do here is what?
Group.
Before we even group, there's a nice little simplification we should make here.
Subtract out 3.
Do we like double negatives?
No.
No, that's what we're going to get rid of first. What should this double negative become?
A negative.
If I'm subtracting a negative, that's the same as adding 2. So I'm going to go like this. I'm just going to make a big plus sign in there. The 2 negatives are going to have a big plus sign.
So it's plus 2y now?
So yes, subtracting negative 2y is the same thing as adding 2y. And now we're going to continue grouping. We'll start on the left. I have a 3x over here. What is like with 3x? Yes, Dakota, the negative 6x. Is there anything else like? Well, there are no other x's. So no. Okay, let's go to the plus 2y now. Is there anything like with,
13y.
it's not 13y, it's negative 13y. You have to include the sign out front. And then is there anything like with the plus 3? No, it's all alone. So now let's go left to right. I have a 3x, so sorry, I have a 13x minus 6x. 13 minus 6 is?
7.
7x's, you betcha.
7.
Now I have a plus 2y minus 13y. If I'm at positive 2 and I'm going down 13,
That'll be minus 11.
it would be minus 11. Minus 11 what's?
7 take away 1.
Minus 11 y. Good, Hassan, thank you. And then, so that's this done, this done, this done, and this done. The plus 3 has nobody, so let's just bring them down here and call it a day. Last one.
Yeah.
Here we go.
That's down.
What are my like terms, Denny?
What?
You're up. You've said nothing today so far. Nope, Denny. What are my like terms?
6.
No, ignore.
1A2 squared, whatever it is.
Okay, ignore everybody. Everyone else stop talking. Denny. 9a squared and it's not 1a squared, it's negative, Denny. Yes. Everyone stop talking except for Denny. Now, Denny, what else is like? I've got, it's not a, it's plus 2a, and Hassan said it, the plus negative a over here. So what's 9a squared minus a squared? It is 8 what?
8.
A squared. That's done and that's done.
Yay!
The students are getting restless. Now I have a plus 2a plus a negative a. What's 2 plus negative 1?
3.
2 plus negative 1.
Negative 3.
Dakota. 2 plus negative 1 is 1. So it's going to be plus 1a. And I don't need to write the 1. So it's 8a squared plus a. At this point, you need to try these things on your own. Anyone who needs to go to the washroom may go to the washroom. The homework is this page right here, and I want you to do all of it. Hold on. Those 3 gentlemen at the door can go. Everyone else has to wait. Try these. Don't worry, Jordan. You got 8 minutes, and then you can go. Javon, yes. Yes. So this is your guys' homework. Anyone who's still here, this is what I want you working on. Do them all. Yes, I will happily go back, Javon. There you go. Yes. Sure. What are you guys doing?